We are thrilled with the tremendous turnout for today's presentation with over 400 registered attendees. TechNation is proud to offer these free webinars as a way to educate and provide valuable information to the healthcare technology industry. We will offer 1 to 2 webinars per month on Wednesdays, focusing on issues pertinent to the biomed, clinical engineering, and imaging services community. We will always schedule the most sought-after and dynamic speakers in the profession. We would also like to mention that many of these same speakers and presentations are held at our biannual MD Expo, which will be held October 1 through 3 in Orlando, Florida. Please visit mdexposhow.com for more information. Next month, TechNation's Wednesday webinars will have 3 presentations. Top companies like GE, Advanced Ultrasound Electronics will present webinars on timely industry information. Visit imtechnation.com for a complete list of all upcoming webinars. A few notes before we begin. Your participation today makes you eligible for 0.5 CE credits. An email survey about today's presentation will appear immediately on your computer once the webinar is completed. We will email you your certificate with the CE credits within 1 week once your survey is submitted. In today's webinar, all lines will be muted, but you can submit questions during the presentation by using the questions feature on the dashboard on the right-hand side of the screen. If you're having difficulty, please email us at webinar@mdpublishing.com. Okay, TechNation would like to thank our sponsor, Fluke Biomedical. Fluke Biomedical leads the world in the design and manufacture of biomedical test and diagnostic imaging products, including electrical safety testers, patient simulators, performance analyzers, automated testing and documentation systems, X-ray tests, radiation safety, and oncology quality assurance solutions for regulatory compliance. Our presenter today is Andrew Clay of Fluke Biomedical. Andrew has spent the bulk of his 20-year career working in many medical device capacities, including R&D, product development, and commercialization. Since joining the Fluke Biomedical team last year, Andrew has been instrumental in the advancement of the industry-leading ProSim patient simulator portfolio. Andrew obtained a BS and MBA from the University of Phoenix. He also earned a certificate in business development from the University of Washington. Okay, Andrew, take it away.
Thanks, John, and thanks, TechNation, for partnering with us to put this webinar on. We really appreciate it. And for everyone who's joining us, we appreciate you taking the time out of your busy day to hopefully learn something. I hope to have a nugget or two for each of you, and we'll jump right in. So I've run into one minor technical difficulty here. Okay, sorry for that technical delay. So if you have questions today, feel free to put them in your chat bar, or you can tweet them at Fluke Biomedical, #OximetryMyths. And you can submit your questions either way, and our social media team will pick them up, and hopefully we'll get them answered at the end of the webinar. What we're going to cover today is the basics of pulse oximetry and SpO2 testing, the pulse oximetry technology, functional testers versus simulators, and how to perform measurements. We're going to talk about a couple of myths today too. While they have no scientific basis, we get a lot of questions in from the field from biomedical engineers as well as OEMs, and when we do field visits we get a lot of questions. So we're going to hopefully cover a few of those today. So a pulse oximeter non-invasively measures the oxygen saturation of a patient's blood. This usually consists of red and infrared light source and a photodetector placed on a pulsing arterial source such as the fingertip or an earlobe. SpO2 or SaO2 is the concentration of oxygen in blood. SaO2 is actually the term used, or can be called SATs. SpO2, saturation percent of oxygen, is SaO2 measured from a pulse oximeter. So why do we measure SpO2? It's an indirect measure of the oxygen saturation of blood. It's also an indirect measurement of aerobic metabolism and associated systems such as the cardiovascular or respiratory systems. It is used to monitor or prevent organ damage, cardiac arrest, or death. Usually a measure below 90% is where clinicians get concerned. So we're usually looking at a measurement between 90 and 100, although some manufacturers want to test lower than that. Which leads us to myth number 1. Using a patient's finger will provide the most accurate pulse oximetry measurement in every situation. Fact is, it depends on the patient and it depends on the situation, and we're going to go through some of the factors that affect SpO2 measurement in a couple minutes. So most of you have seen different sensors around the hospital, and they're placed on different portions of the physiology. Kids and neonates, babies, they put it on the foot because if you put something on a baby's finger, they want to pull it off. And so they put it on the foot, which is a pretty good measurement place. Most adults, we use the finger. You're pretty familiar probably with the transmissive sensor used, clip-on sensor on the finger. Other factors that can affect the measurement are tattoos or skin pigmentation can block the light. Hypothermia or smoking can cause a constriction of the capillaries. Anemia. Medication can affect the various anaerobic mechanisms. Nail polish. And there are others, such as movement or light, can affect the measurement as well. Next myth. Calibration references are derived using exact scientific methods. Fact is that there's no primary calibration reference. References are derived using known cause and effect, and I'm going to walk through that in just a second. So the references are derived by each manufacturer. They create what's called an R-curve. The R-curve is generated from a set of clinical trials done by each OEM manufacturer on each model of sensor. And basically what happens during the clinical trial is that patients are deprived of oxygen, and then there's a measurement. The direct measurement is typically a blood gas or something like that, which gives us ground truth. So that's why we call SpO2 an indirect measurement, because the direct measurement would be invasive. The indirect measurement is non-invasive. And this R-curve then goes into a tester, and it also goes into the medical device. And there's an R-curve, like I said, per sensor per manufacturer. This is an example of a transmissive technology, the clip-on, a finger if you will. So both a tester or a finger can be placed into this sensor. And usually there's a red and IR LED transmitter on one side and a photodiode detector on the other side. So light and different wavelengths is shined through the finger and detected on the far side, and that measurement is compared to the R-curve to then come up with a % oxygen saturation. So the tester blocks the emitter and emits its own light source into the photodiode is how a tester works. Another technology that we're seeing more of is what's called reflective technology. Basically, the transmitter and receiver are on the same plane, and this can be placed on a finger, or I've seen forehead and some other applications. There aren't too many testers that test reflective technology yet. There are other types of technology in this space, specifically the Massimo Rainbow set. It actually takes more than SpO2. There's a number of factors and measurements that it takes and displays, and therefore you need a slightly different tester to be able to test this. Massimo, along with others, are creating new ways to use plethysmography to measure a wider range of vital signs. There's some listed here, but there's also looking at glucose as well. So when you're looking at one of these sensors, you have to make sure that your tester is capable of testing all of the different parameters that are presented from the sensor, not just SpO2. So our next myth. SpO2 simulators produce the clinical equivalent of oxygen and carbon dioxide carried by the blood to simulate oxygen deprivation. There's no available tester today that mimics how the oxygen and carbon dioxide are picked up and dropped off in the blood. That would require fluid that can pick up oxygen moving through a pipe, basically. And so what happens is our testers mimic the R-curve through the light emission and not necessarily how the oxygen moves through the body. When we talk about simulators versus functional testers, what we're talking about is the standard. The 80601-2-61 goes through what's a functional tester and a calibrator And what we really need to focus on is primary versus transfer standards. So ground truth is where you would start during a clinical trial where you're measuring blood gases. Then we go to indirect measurement, which is the SpO2, and then a tester is one removed from that where we're taking the R curve from the medical device and then simulating that. And that's where the standard actually makes a distinction between a tester and a calibrator. Again, that's 80601-2-61 is a good source for looking at the differences between those. Next myth. It is not necessary to use a functional tester to complete preventative maintenance to verify pulse oximetry. Fact. Functional testers are the most reliable way to verify performance and ensure regulatory compliance. As most of you saw, CMS issued some guidance a while back, I think in December, about following manufacturer guidelines or creating your own risk management program. This is where we highly encourage you to go back and look at the manufacturer's recommended maintenance in the manual, which will talk about the use of a functional tester. I think there are some people out there that still do use a finger once in a while, your own finger, to test the pulse oximeter, and that may not be the most accurate way to do that. Here's some examples of functional testers, and these are near and dear to us. These are Fluke products, and I'm going to talk a little bit more about each of those. Next myth. All oximeter sensors are the same quality and will last the same length of time. Every oximeter sensor is different. So between the manufacturers, they use different components, different R curves, and they assemble them in different places in the world with different quality control standards. So that's why we recommend testing them annually, and we're going to get to that as well. But yet be mindful that each set from each manufacturer could last a different amount of time. So Toby Clark, who wrote the MDQA book, along with Fluke Biomedical, recommends that patient monitors and functional testers that test SpO2 be tested annually. Some of the testers input a signal directly to the monitor. Some can test the cable for continuity, and some can test, most test optically, putting in an LED signal. This should look pretty familiar to everyone. This is actually what's called out in the book and probably what's in most of the medical device manufacturer guidelines. So we think this test will take about 10 minutes. The first thing we look at is the physical condition. Is the cord cracked or broken? Is the sensor intact? Then we would look at electrical safety using an electrical safety tester or analyzer. And then we would do any preventative maintenance that's called for in the manual. This could include cleaning, looking for cracks in the LED, or any other physical defect. Then we would move to performance testing, where we look at heartbeat accuracy, O2 saturation accuracy, recorder operation if one is installed, alarm functions, mostly at the lower limits, verify battery power, and any model-specific tests, again, called out in the manual. And then the one that's near and dear to everyone, documentation. You have to record that, the test results and whether it passed or failed. I'm going to show a short video. The audio is disabled in this particular situation, but you can watch this video at our website, www.flukebiomedical.com. And what we're going to go through here today is our spotlight. This video in total is about a minute, and what we're going to show is how easy it is to test SpO2 on a monitor. This particular monitor is a DFib, and what we're going to do is power up the simulator or the functional tester. And then we need to make sure that we select the right R curve or the right manufacturer. Most of the functional testers will have a number of R curves built into them, and you need to check the manual to make sure which R curve to use. Note that some manufacturers license SpO2 technology from other companies. So just because you have a certain type of monitor does not necessarily mean that it's the same for the SpO2 or the R curve installed in the device. So check the manual to learn about that. And so we have 97% on the functional tester and 97% on the monitor. So what we would do at that point is we would lower it to whatever our alarm threshold was. Let's say it's 94, and then we would check to make sure that the monitor alarmed appropriately. We're going to run through a couple of our products. So we can SpO2 test with the ProSim 8. This is the only instrument on the market capable of testing the Rainbow Massimo set. It has 8-in-1 capabilities, and we have a pretty substantial amount of evidence that says that we can complete an annual PM in about 5 minutes, including a video that shows that. Fully automated testing, we have a set of preset templates as well as optional PC software and built-in automation. For quickly testing SpO2, we have our Spotlight. It's simple with basic measurements and easy navigation. It can be paired with your own simulator or some of the other instruments from Fluke Biomedical. Pictured there is the ProSim 4. For attending this webinar today, we're going to allow the download of an SpO2 app note. And it was written by Dennis McMahon, who's local to the Seattle area. He was a clinical engineer for many years and is now an instructor at North Seattle Community College and is also the chair of the Washington State Biomedical Engineering Association. You can connect with Fluke Biomedical across a host of social media, including Facebook, Twitter, LinkedIn, YouTube, and Google+. We have a lot of education opportunities available at our website at www.flukebiomedical.com. Our Advantage training offers a lot of videos, self-paced training, quizzes, white papers, app notes, and a slew of videos. And stay tuned because there's going to be a lot more activity on our Advantage training where we're going to be expanding that as the year progresses and into next year. And that concludes my presentation. We're going to take some questions now.
Okay, Andrew, the first question we had came from one of the attendees, Robert. The question is, SFFD uses Zoll monitors with SpO2. Their literature states to use their ring finger of the non-dominant hand, but I am unable to get a reason behind that statement from Zoll. Does the finger clinicians use really matter?
So, like I said earlier, there's a lot of factors that go into where you measure. So I'm sure the manufacturer has a best placement, but you need to look at the clinical situation, and the clinician, the doctor, the nurse that's actually wanting the measurement taken, needs to figure out where is the best place physiologically to place the sensor. So while you should always try to follow the manufacturer's guidelines, that's probably the best place to start. There is also a number of factors that we went through about you know, are they a smoker, are they hypothermic, are they anemic, etc., where there may or may not be a better place to put it, including the foot, or, you know, for people who are aged or have diabetes, or if you're in combat medicine, they may not have that limb to actually attach to, so you got to look for the next best place.
Okay, Andrew, here's another question. Can the Fluke testers be used with every kind of manufacturer?
So we are preloaded with a number of manufacturers, so we need to check to make sure that we have the R curve loaded for the manufacturer that you have.
Okay, here's another one. You mentioned that the ProSim 8 is the only device that can be used with Massimo Rainbow sensor. Massimo has an SpO2 simulator. Can it not do the Rainbow sensor? What will an analyzer show if the sensor, oops, sorry, I was reading the next question. Yeah, can it not do the Rainbow sensor?
So I do not know the capabilities of the Massimo test product. You'd have to talk to Massimo about that.
Okay, great. Here's another one. What will an analyzer show if the sensor under the test has connect light intensity but unexpected red or R wavelengths for the R curve of that particular sensor?
I'm not sure I follow the question. Can you ask that one more time?
Okay, looks like what will an analyzer show if the sensor under test has correct light intensity but unexpected red or R wavelengths for the R curve of that particular sensor?
So if I'm following the question, so the tester sends data via the LED into the sensor, and then that's interpreted on the patient monitor or the standalone SpO2 device. If there's anything, a transient or light gets in, then the measurement could be compromised in some way. It could be a little higher, probably a little lower, actually. What you have to do is to look for stabilization. So once you place the sensor on the tester, let it set for a second or two to make sure it's stabilized. Now, I'm not sure if you're using the wrong R curve against a different R curve for a different manufacturer, you could get any number of unexpected results. It could be a little high, it could be a little low. You need to make sure that the R curve matches, because each R curve is derived for each sensor. I hope that answers that question.
Okay, I got another one here. What is the difference between Masimo and Nellcor sensor? Is it just a preference?
So it really depends. When you're talking just SpO2 between Masimo and Nellcor, each of those will talk about their own features and benefits. But there is a difference when we talk Masimo Rainbow. It does a few more measurements from the same kind of measurement technology.
Okay, next question. What if the red LED is orange?
Well, it's about transmission of the wavelength. And I've not seen an orange one, but I suppose some of them could look orange, but it's in the red or the infrared spectrum.
Okay, here's one. What is the appropriate range to test?
So clinically, we're looking at 90 to 100%. Some manufacturers want to go lower, perhaps down to 70%. But clinically, you're looking above 90. Anything below 90 and your patient's in trouble.
Okay, I got one here. When the Fluke ProSim 8 is calibrated by Fluke, do they optically calibrate the finger probe, or is it just electrically verified?
Both.
Will the new earlobe sensors work on the ProSim 8?
So I need to look into that. I believe that they do if they mechanically fit. The problem is sometimes the sensors, when they get too small, can't fit across the sensor or the emitter. So it really depends on mechanical fit at that point, and then again make sure that we have the right R curve for that manufacturer.
Okay, how about, does Fluke sell anything to simulate faulty or failed sensors?
No, we do not. So the failure or fault could be electrical, in which case we do have a product called the Index 2 LXFE, which does do electrical testing. However, to look at whether or not you're within saturation accuracy, we can do that. But we don't insult the other faults except for movement.
All right, I've got one here. Some pulse oximeters indicate SaO2 and some indicate SpO2. Which is right?
So they're both accurate. SaO2 is the clinical expression. SpO2 is SaO2 measured with pulse oximetry. So either is correct or appropriate.
Here's a good one. Is noise cancellation technology true in SpO2, or is this just a marketing ploy?
I'm not really familiar with the noise canceling technology. I've heard of it, but I haven't seen it work yet. So I don't want to disparage that technology, but I have not seen it.
On the Fluke testers, what is the percentage of error allowed or accuracy specifications to simulation produced?
So on I don't have it off the top of my head, but our data sheets will reflect what the accuracy is. And if whoever asked that question wants to pop that in the chat box, our social media person can get back to them with the correct answer.
Okay. How long is the pulse oximetry test procedure?
It's about 5 minutes, perhaps as high as 10 minutes.
All right, here's another one. How often should I complete testing?
So according to Toby Clark, that's annually.
Okay, I'm going to try to pronounce this correct, but it says, while testing WRAPE on sensors by ProSim 8, I faced problems to get right readings. I need to hide testing finger from light to get right readings. Is that correct to do?
So the short answer is probably, because if you can't get a good mechanical fit where the light sensor is blocked off, then you could get errors introduced by either ambient light or light escaping from the diode.
These are great questions, everybody. Really appreciate these coming in. Here's another one. Does Fluke have any other available documentation regarding medical equipment preventative maintenance procedures other than what was available in the book offered?
So we do have, besides the medical device QA book that talks about a medical device QA program, we have several app notes on our website that talk about our testing of their various products.
Okay.
So if they're looking for a specific one, they can call it out in the chat box there, and we'll try and find the appropriate app note.
Great, great. Here's one. Has the accuracy of the spot improved upon the accuracy of the index?
You know, I'd have to go back and look at the spec sheets for that. The short answer is they're probably pretty similar.
Not quite sure if this one's an astronaut. Do any of your products provide electrical testing for SpO2?
You faded out there just for a second. Could you read that one more time?
I'm sorry? Do any of Fluke products provide electrical testing for SpO2?
Yes, our Index LXFE does do electrical testing.
Okay, we got a bunch more just came in. What if the sensor causes it to continually flash when it doesn't read a value? Is it failure of the LED or a kinked or broken wire inside?
So it could be any number of things. If the transmitter continues to transmit but the receiver doesn't receive, it could be the functional tester's not outputting. It could be ambient light. It could be a broken cable. Basically, it could be any number of things that's going to have to be troubleshot on the spot.
Okay, here's one. Can you interface the ProSim 8 with a computer? If so, what parameters can you control?
So the short answer is yes, you can. We offer PC software called Answer, which is a test automation solution, and that interfaces through a PC. And basically, you can automate any function in the ProSim 8 according to your test procedure.
Okay, here's one. If there is not a standard for SpO2 and each manufacturer creates their own R curves, then is SpO2 on the testers traceable to, I can't quite understand that,
NIST. So the short answer is no. Because we are, I'll say, 2 levels removed from ground truth. So you have ground truth, which is blood gases, etc. And because a person is not NIST traceable, therefore we don't have a NIST traceable spec for SpO2. That's the short answer. The longer answer is we're several levels away from ground truth.
We'll get them to you.
Okay, that's going to wrap it up for the questions portion of this. Attendees, if you have any further questions, feel free to tweet them to Fluke or send us to webinar@mdpublishing.com, and we'll make sure that all questions are answered appropriately. Don't forget, everyone, that your participation today makes you eligible for 0.5 CE credits. There will be an email survey about today's presentation that will appear immediately on your computer once the webinar is completed. We will email you your certificate with the CE credits within 1 week once your survey is submitted. We'd like to once again thank Fluke Biomedical for sponsoring today's fantastic webinar. Their support is greatly appreciated and very valuable information for our industry. Thank you all for participating, and we look forward to seeing you in the next webinar. Thank you so much.